With the discounted payback, we try to correct one of the problems with the payback method, and that is that it ignores the time value of money. So what we do is we look at, instead of looking at these cash flows, we look at the present value of these cash flows based on some discount rate. So I've got an example here of this is a project, cost us $12,000 today to start the project, and then it's going to generate these cash flows in the future. We have a required return on this project of 10%, and what's the discounted payback? So the way we do that is first we're gonna find the present value of all the cash flows here, and now I think about that as I'm just going to use the present value formula. Now the present value of cash flow at time 0 is just the cash flow. And then the present value of all the cash flows after that, well, I'm just going to take the cash flow and I'm going to divide by 1 plus the interest rate. In this case, it's 10%. And I'm going to raise it to the power of when that cash flow occurs. So the present value of the first one would just be that amount, 5,000 divided by 1 plus 10% to the first power, because I get it 1 year from now. And then the next one's going to be 4,000 divided by 1 plus 10% to the second power. And then 4,500 divided by 1 plus 10% to the third power. And I didn't get that right. 4,500 divided by 1 plus 10% to the third power. And then 3,000 divided by 1 plus 10% to the fourth power. And that's going to give me the present value of all my cash flows. Right now, to me, that's the easiest way to do it. I have some students that insist on, they want to calculate them all this way using the calculator, which I think to me is a horribly slow way to do this versus just dividing them by 1 plus the rate to the exponent. But you can do it that way. N is just going to be, whenever that cash flow occurs, the I is 10% in this case. We're looking for the present value in all of these cases. The payment in all of these cases is 0 because we just have one. I should have future value here, one future value. So in this case, you would put the 5,000 here as the future value, the 4,000 is the future value, all right? It's going to be 10 every year, 4,500 in this case, and then 3,000. So you can do that, and the only thing that's going to change here is the N. It's going to be 1, 2, 3, 4, and then put in the cash flow as the future value. There's no payment because nothing happens in between. And then the calculator will spit out these present value numbers for you. All right, again, for me, it seems far easier to just divide by 1 plus the interest rate to the power that the year you receive it, but however you want to do it, right? And then now, once we have these present values, finding the discounted payback is exactly the same method we went through to find the payback. We are just going to use the present value. So I'm going to keep a cumulative total in terms of present value. So all I'm doing is each year I start with minus 1,200, and the next year I add in this 4,545. Okay, the present value of the money I received that year. And the next year I do the same thing. I just add in those numbers in terms of present value, right? And you can see that it turns positive between years 3 and 4. So the discounted payback is going to be equal to 3, and then I'm going to have to take 768 divided by, and again, remember, use the present value here, 768, and then in terms of present value, here's how much money I received the next year. So the discounted payback in this case is going to be 3.37. Okay. Now I may have that worked out in the slides here. There I do. So here's all those present values. Here's the cumulative totals. And here's how I get the answer, 3.37. Okay, so it's a good example for you to work through. Be sure you can calculate these present values and find the discounted payback. Here's an example for you to do. So try to work through this one. I'll give you the answer here. Discount rate in this case is 14%. Just copy these over here. Calculate their present values, discounting them at 14%. There's all their present values, and so is a cumulative total. See, it goes positive again between year 3 and 4. And the answer here is 3.55. Hopefully that's one of my choices. Yes, B. 3.55. So yes, and I've got this worked out in the slide there too. Okay, 3.55. So that's a good one for you to practice doing the discounted payback method. I think I have some in the handout also for this section. Okay, so I'll stop the recording here and pick up on the next slide.